Hey everybody, it's Dr. J, and today, we're talking about acid dissociation equilibrium. Yes, we're talking about Kas and pKas. Let's talk about chemistry. All right, so an acid, we talked about that before, but once again, an acid is a compound that will ionize in solution. All right, in this case, we usually talking about water. And when it's doing this, right, it's going to form an H plus ion. Okay. Now, what we're going to find out is that as it dissociates, we got this H plus ion, but we're also making a counter anion. In this case, that's our conjugate base. Okay. So when we form this, our equilibrium expression is going to look like this, right? Products over reactants, what we normally are used to with our case. Now, the equilibrium constant, KEQ, is often given a special name for acids. In this case, that's just going to be Ka, all right? Or our acid dissociation constant. Now, this is a key thing you guys want to understand. If you got a bigger Ka, so the larger the Ka, then basically you're going to have more H plus concentration. All right, that's what's being produced, right? Essentially, if you have a large Ka, you got a strong acid. Okay, that's as simple as it gets. The bigger the Ka, the stronger the acid. The smaller the Ka, the weaker the acid. So when we were talking about with pH, it's the same thing that's going to apply here, right? pKa equals to negative log Ka. That's it. Very similar, right? I told y'all. If you know that pH equals to negative log of H plus concentration, or if you know that POH equals to negative log of OH concentration, you kind of know all this stuff, y'all. Okay? So get in the habit. P blah 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 equals to negative log of whatever. Okay, in this case, we're talking about concentrations. All right, so everybody, here's a list of different things. I'm not going to go through this whole list. All right, we're just going to go through some of these. Okay, so let's go to the very top, the tippity top. We got hydrotic acid right here, HI. Okay, so we can see that the conjugate base of our acid is basically the thing without the proton. That's how we have to think, everybody. It's the thing without the proton. In this case, just our I. So what we're going to see here is that our Ka is very, very high. And like I mentioned before, if you got a large Ka, you have a very strong acid. Now on the other end with our pKa, basically the smaller the pKa, the stronger the acid. So it's the opposite effect taking in place with our pKa. So if you got a small pKa, then you got a strong acid. If you got a high Ka, you got a strong acid, right? So if we go at the very end on the other spectrum, all right, let's go to hydrocyanuric acid, right? Hydrocyanuric acid, we can see that it's going to be HCN, and then the conjugate base, right, is just without the acid, the H plus, is going to be our CN. So in this case, our Ka is 4.9 times 10 to the negative 10. Very, very small number, all right? And in this case, we got a very small number. It's still an acid at the end of the day, but it's a very, very weak acid, okay? And if we look at our pKa scale, that's going to match it, right? So we've got a small Ka value, expect a very high pKa value. In this case, we get a 9.3. Okay, very high for an acid. Now, this is going to let me know, right, the strengths our base, right, our look, if we look at our Ka and then we look at our pKa, we can tell, right, if we're going to have a strong or a weaker acid. Okay, so we got to know these different things. Know the trends. So you know the trends, right? When you're looking at this data, you're not going to be confused, right? Ka, yo, we got a big acid. Small Ka, we got a small acid. I got a small pKa, but I got a strong acid. I got a big pKa, but I got a weak acid, right? Know those trends? If you know those trends, you guys will be set.